We are very excited to be here. It's particularly right now and with this topic. Marc and John, I don't know if you felt this way, but in the weeks leading up to this conversation, as I've been working with my clients, I really couldn't help but think how timely this conversation is to be having. We are, and my clients are, recovering from a lot of complications that we experienced over COVID, supply chain constraints that led to some panic buying and over-indexing on inventory, and the typical toolbox and techniques that they're using are not as impactful until we help engage with them and say, hey, let's apply 80-20 to this and really amplify our efforts in what we're doing. So I don't know if you guys are seeing that or felt that coming up here, but I certainly am.
Yeah, Jennifer, I see it as well. You know, I call this, you know, in terms of inventory, it's you know, too much and not enough. They typically have too much of certain items, not enough of the other items, but in order to complete the bill of material, you have to have everything. So deliveries are suffering, on-time delivery is even getting worse, and yet we find that inventory is going up overall. So this is a big problem.
Well, absolutely. It's the same in a lot of places where everything's start and stop, pull off this job, think you can start it and you can't. And it's really killing the on-time delivery, as Marc mentioned.
Yeah, I agree. Well, let's jump in. We're going to give a little bit of background and then talk through some specific examples. We have intentionally reserved some time at the end to address Q&A. And so please chat in your questions, because if we're going to mention some of our favorite lean tools and how we put them on steroids, but if we don't mention your favorite or something your company's facing right now, please type it in. We want to talk about it. So let's go back in time, post World War II. So coming out of in the mid 40s, and Japan experienced a real devastation during the war. Their GDP and their economic position had really regressed and wiped out all of the 19th and first half 20th century progress that they had made building their economy. So they had to move into a pretty serious recovery phase. What happened, if you're a historian or like that sort of thing, was truly remarkable. Actually, it's referred to as an economic miracle, because they went through a recovery phase and then for decades experienced astronomical growth and improvement. But what I want to talk about is that recovery portion. It required a lot of collaboration between major manufacturing, suppliers, banks, unions, all really working together through this economic downturn. And not the least of which player was Toyota. So the Toyota and the Toyota family were automotive manufacturers. They wanted to compete on a more global scale, but they were facing incumbents like the American manufacturers, Ford, GM, who had 8 times the production demand that Toyota had at the time. So not only did they have much more demand, which as manufacturers, we understand then the implication on the economies of scale, but they also had much more modern manufacturing equipment and access to capital, all of which Japan and Toyota really couldn't access due to the economic situation that they were facing. But they didn't quit. They pursued excellence and developed what was and is called the Toyota production system. This is the basis and foundation for what we know now as lean and lean methodology. And we also know the success story of Toyota, which is why we love lean. They pursued excellence and they did enter the global market and become a major market shareholder in the automotive space. And so it's hard to argue with the success that we can realize when we pursue that level of operational excellence. That said, a lot of us forget the very first step of lean, which is to simplify. So I want to rewind, go back a little further still, early 1900s. And that's where the gentleman on the right comes in this slide. His name is Vilfredo Pareto. And Pareto was an Italian economist. And what he found in his studies and all of his data and analysis was that of any data set he looked at, a very small portion of that data made up a disproportionate amount of the results. So this commonly became referred to as the 80-20 principle, or the law of imbalance. And we see this today in our business. your business too. You sell to a myriad of customers, and I would bet you that the top 20% of your customers make up 80% of your revenue. And that only of all the products and services that you sell and offer, a very small number, probably 20% of them, make up 80% of your revenue. So we know this in business. We know this in our lives too. Everyone here at Strategex doesn't just work 80-20, we live 80-20. And so, you know, I encourage you to check out some of our other recordings and webinars where we talk passionately about how 80-20 can apply to life as well. So we have these two disciplines. We have lean methodology as developed and demonstrated through the success of Toyota. And we have even earlier, a half century prior to this 80-20 discipline and thought process. So I want to tell you how these two work together. This is a chart that is studied over a culmination of businesses that have employed lean. And what it tells us is there is a direct causal relationship between the sigma level that you operate at, how complex your process or operation is, and our ability to achieve a greater, higher first pass yield. What is that and why does it matter? First pass yield is a percentage measurement. It is how often you can do something through a process the first time without making any error in that process. So again, your ability to successfully do that with no error is directly causally related to your sigma level and the number of steps in that process. So for example, if you are operating at a 4 sigma and your process has 3,000 steps, I like to think of process as how many products do you have? How many customers do you sell to? How many orders do you have to take? Mm-hmm. So since we're talking to manufacturing, let's think about products. If you have 3,000 products and you have to do a changeover, a setup, a small run of that product, a changeover, a setup, another small run of the next product, and you operate at a 4 sigma, your first pass yield is 0. You are never perfect at that process the first time you do it, which means you have rework, you have scrap, you have engineering change orders, you have to go correct something with the customer, you have quality issues, warranty issues. That is the implication of that. We want to increase our first pass yield because we know it reduces all of that rework, scrap, frustration, and cultural challenges that we have in our workplace. Also, it so happens that every 20% increase in first pass yield is typically a 5% reduction in cost of goods sold. So we know there's some financial motivation there as well. So sticking with that 4 sigma example, if I'm 4 sigma and 3,000 parts that I have to manufacture, if all I do is first go north with 80-20 and say, I'm simplifying my 3,000 down to 100, I can improve my first pass yield by 54%. If I go even further, really sharpen the pencil and get that down to 40, these are the 40 critical few that I really need to focus on. And I say, okay, that's it. I've simplified. Now let's apply all these lean methodologies and techniques. Let's go green belt, black belt, Kaizen, high jump, throw all the tools at it. And let's get perfect on these 40. And I invest all the resource, energy, effort needed on those 40 to move up a sigma level, which is an investment. Now I can get to 99% first pass yield. So it's the combination of going first north with 80-20, then east with lean that really results in this. This is how we put lean on steroids. So focus on the critical few. How do you know what critical few to focus on? For this, we do a couple forms of data analysis. I told you I'm going to do backstory, and then we're going to jump into examples. I have 2 more slides of the type of data analysis we look at, and then we're going to talk about some practical applications of this. But I want us to speak the same language, so I need to go over these so we can all understand the examples that we're going to talk through. The first type of data analysis we do is called a quartile. This is something that you could do. I'm going to give a high level explanation. Again, we have an excellent recording. I think Marc did it. It's on our website. Marc that's speaking here with us today, of depth and detail on how you can do this analysis yourself. So if you're curious, I encourage you to check it out, but I want to explain it for consistency today. So to run a quartile, we take all of your products, do an extraction of everything, every product that I sold over the last year, for example, then sort them in descending order from the greatest dollar amount product that I sold all the way down to that tiny washer that I actually took and processed an order for 50 cents and invoiced somebody. So you're gonna rank those in descending order, top to bottom. Then we are gonna break those into quarters, hence the name quartile. So in this example that we're showing, let's say you have 200 products. Your top quartile, the top 25%, would represent 50 of those 200, your top 50. And that is typically, we know it's more than 80% of our revenue because if it was 20% of our products, it would be 80% of our revenue, but it's 25% of our products. So it's actually, we observe not 89% of your revenue, typically. The second quartile, so the next 50 products, those tend to make up 7% of our revenue. And the bottom half of our products altogether that we have to change over, set up, custom quote, all the activity that comes in with those long tail of half of the products we sell are only 4% of our revenue. So the order is 89,731. Now here is the provocative part. If you look at the overhead, energy, effort, resources of your organization, they are spread equally across each of these quartiles. So about 25% of our overhead, effort, energy is spent in every quartile, despite how much some of these do and don't contribute to our overall performance as a company. Now, I know we have a manufacturing audience and a lot of engineers and savvy people, so you're probably already doing the math on what the next column would be. The implication on profit is pretty massive. If I have 89% of my revenue and it only takes 25% of my overhead to produce, I actually make more than 100% of the profit I report in this quartile. I make close to 150% of my profit in the top quartile. But how is that possible? How can I make more than 100? Well, the answer's in the last three quartiles. If you're good, and I mean really good, you can break even in quartile 2. But we systematically give money back and lose money by choosing to transact in quartiles 3 and 4. We lose a ton of money in the 4th quartile. So this is a great barometer and temperature check to say, where should I start considering simplification? What does my portfolio really look like? The thing that this particular quartile doesn't capture, because it's one dimension, is say I have my number one most important customer that needs to buy my product 200 from me. They buy my product number 1, 2, 3, 4 also, and in big volumes, but they expect to buy 200. So I can't start simplifying and removing complexity from my portfolio just based on my quartile of products, but it gives me an indication. Instead, what we do is a second form of analysis called a quadrant.
So Jennifer, just as you transition to the quadrant, just to remind everybody that, you didn't go through the customer quartile, but it looks the same. It's 89,731. The same products and customers look the same.
Thank you, Marc. Absolutely. And you'll do both of those, and we encourage you to do both of those. So now that one, I would argue you could simplify some based on the quartile of customers, but I wouldn't do it on the products. So, and we're here talking about manufacturing. So to Marc's point, you would do a quartile on both, and then we look at the lens of the transactions between customers and which products they buy for us to make this quadrant analysis. So what you have here is along your x-axis, you have your products. We designate a product as any of the critical few small number of products, about 20% of what we make, that make up 80% of our revenue. And the B is, again, the small number of products oh no, excuse me, is the very, very large number of products, 80% of our products probably, that make up only 20% of our revenue. Customers, AB designation, absolutely the same way. And so what we look at then is the quad one will show the intersection of our A customers buying our A product. And this we call the fort. This is the base and the majority of our business. We need to protect this at all costs. We need to be world-class in the way we manufacture for and service the business that we transact in this quad. From an operations standpoint, you know this is good business for us because it is long run, standard product to very, very big customers that buy in big volumes. We love quad one business. And it represents 64% of our revenue. That's just math because it's 80 from the A customers times 80 from the A products, which 8 times 8 is 64. So that's how it gets to be about 64. Again, the fort, dig a moat, put a drawbridge, one way in only, whatever you need to do to protect your fort of your business. So that brings us to quad two. This was my example when I was explaining the quartile, and I said, but what if your number one customer needs to buy product 200 from you? It's the necessary evil. It is short run, sometimes special products, but again, it's to a big customer. So I'm likely expected, based on my value proposition to that customer or market, to provide this product or service. So I need to get creative with the ways I do that and simplify that, but it is a necessary evil for my business often. Again, this is about 16% of my total revenue. Quad three, we're back to long run standard product. Manufacturing operations, we like quad three too. It is to a small customer, long run standard product to a small customer. So I might have to pick smaller lot sizes. I might have to transact more frequently. So how can I change some of the ways I do business to think about that differently? But I like quad three. Quad four, the last quad, short run, special product to tiny customers, is the death of us. You cannot realize a profit in this quad. It is only 4% of your revenue. So because again, it's 20 times 20, so 2 times 2 is 4. And yet it takes up 25% of our overhead, similar to the quartile. So at 4% of my sales, 25% of my overhead, you cannot realize a profit. So there is an acronym in there. I'll let you figure it out, but that is what we call quad four. And this is where you drive simplification efforts in your business. You need to focus on, how do I get out of quad four? We work with clients on what we call product line simplification, PLS, and we start very aggressively tackling quad four. What we're here to talk about with you today, though, is quad one. And how do we become world-class manufacturers and focus all of our lean efforts in quad one activity? And so now we're done with backstory. We can all speak the same language and we can talk through some examples. So John, can you lead us through one of our first examples we have?
Sure, absolutely. Thank you very much. Excellent job covering the 80-20 and product line simplification. You know, I think lean has gotten kind of beat up over the years. It's been called anemic. And it's not that people said it didn't accomplish improving processes or getting rid of waste. The question was how much it impacted the organization. And it was seen as a bottom-up strategy by manufacturing. But with 80-20 and PLS, we can put lean on steroids. Now, I'm a pretty simple guy, and I like simple operational processes. So I want to show you an example of a very complicated product, a 8,000-pound machine with thousands of parts and wiring and servo systems and PLCs. And that product was manufactured under a process that I call the dreaded village build. Now, for those of you that don't know what a village build is, let me take you through this very fast. Hold on to your seats. So with the beginning of a village build, normally sales is working with the customer. They're getting their specifications. They're coming up with this custom quote, and then hopefully you get an order. Then to get the order, they have to go back in and figure out the comparison between the quote and what the customer order is. sit down, pull everything together, and have a meeting with engineering. Engineering is now going to take that. What's the job that looks like this before? Did we do one of these a year ago? They pull a bill of material. They start getting rid of, hopefully get rid of assemblies you don't need, so you don't buy parts you don't need, have to design some new things, probably have to go back to the customer, talk to them a little bit more before they can start releasing this information to purchasing. Now, purchasing is going to go ahead, do the quotations, get the best pricing, probably find some obsolete parts from the last time around, but eventually they can get those orders into the suppliers. Now, we also had a machine shop internal to our company. And so those things would get scheduled in the machine shop. Often the machine shop had to go back into engineering, ask those kind of questions, as did the suppliers quite often. But eventually those parts started coming out of the machine shop. They started coming out of the suppliers to receiving, who would take those and put them into bins and baskets and shelves marked with that particular order, while production took a look and say, do I have a place on my floor to plop down this big frame and then pull all of these parts around it and start to build it? Inevitably run into some problems, have to go back to engineering, ask questions on how to build it, go back to purchasing, find out some questions on parts, jump off of jobs back and forth until they could eventually power it up and start to do some internal tests. That would require engineering to come back down, put in a special PLC program, so eventually we could call the customer in and do a buy-off. That always involved assembly, it involved engineering again, it involved sales again, and all of this took an exhausting 26 weeks to get done. So how do we simplify something like this? Well, of course, we're going to use lean techniques. I love lean techniques. We can reduce direct labor, reduce inventory, but there's also something called agile manufacturing, which is more of a pull system that is made to react very quickly to customer demands. Now, I'm a pretty selfish operations guy. I want it all, and so do my customers. And with the backdrop of 80/20 and PLS, we can implement a system called inline. So how do we go from village build to inlining? Now, as I put these up, take a look and think about, there are some of them are lean, some of them are agile, but how much easier they are to implement and how much more of an impact they can have on the organization, as well as sticking power. So the first thing we have to do before we do an inline process is inline the machine or the product. So we standardize, we modularize across different models for both the machine, but also things like the bill of material and the assembly drawings. We eliminated the machine shop because our customers don't care if we're making parts or not. They only care about our equipment. We also eliminated the village build, good riddance, set up assembly with work cells. In those work cells are every part that the assembly crew needs for any possible combination of machine. And those parts are actually reordered by the assembly people themselves because we implemented blanket orders and Kanban systems. In addition to parts, they have all the instructions, all the tools, all the fixtures, everything that they need to build this product, including being able to do some testing ahead of time. Scheduling was very, very simple. It was a matter of going to the board, putting in the options and features, putting the date in there and walking away. Assembly had everything they need. They could take care of it. We actually moved this 4-ton machine down the production line, taking the sub-assemblies out of the cells and putting them on the machines. So the testing was also the same every time because we modularized the PLC program and the Windows program as well. So it was very simple, fast, power up and test. So what kind of advantages did we see as a company? We saw a ton. But the major factor is that engineering and purchasing are no longer tied to a specific order or a job. They can spend their time on new product development, new features, new options, supply chain issues, finding new and better suppliers. But take a look at the results that we actually saw. Material costs were down anywhere from 10 to 34%, depending upon the model. And we turned that inventory 4.5 times faster while using less than 50% of the direct labor we did on the village build system. And let's not even forget about the 300 or so engineering hours that went into every job that was simply gone. We took that process of 26 weeks, simplified it, and made it as fast as 10 to 12 weeks. But that's only the benefits to the company. What about the benefits to the customer? Because they know what we're doing. And with 80/20, with PLS, with inlining, we can use manufacturing as a strategic weapon to gain market share. So let's take a look at some of those benefits to the customer. And I'm going to tell two short stories. I had an A customer, big customer, was getting killed with warranty on their truck vehicles. And they had ordered 3 passenger machines. And they came fairly late in the process and said, can we change those to truck machines instead of passenger machines? Now, in the past, that would have been absolutely impossible. They asked me if we could do it. I said, yes, we can do it. They said, how much are you going to charge us? I said, I'm not charging you anything. They said, okay. I went down to the assembly line, got the assembly people, showed them what I was changing. They had all the instructions, everything they needed. We'd actually started to assemble this product. Now, they removed some parts, move them up into different locations, maybe add a couple more parts, but we took it off the line and we shipped it on time. And about a year later, they told me that they saved close to $1 million in warranty costs. I had another customer that somebody drove a fork truck, a tow motor, into one of the machines, taking it out of commission. You can only imagine with a village built system that we're looking at least 3 months, if not longer, to get that machine back up in production. But with inlining, we took a look at the pictures, we pulled together all the parts that we thought we needed, we took the instructions that may be needed, sent a couple people down, and in under a week, we had rebuilt that machine and got it back up in operation. That is what's called taking care of those A customers, building that moat and keeping them in, as Jen mentioned. So that's just an example of using 80-20, putting lean on steroids with a village build application. Now, Marc will take you through similar process, but for batch processing. Marc?
Yeah, thanks, John. So we do see village build, but probably more common we see, batch processing, and the definition of a batch processing in manufacturing is, where they have dedicated manufacturing cells, and the parts move in batches from cell to cell. And when you see this diagram, this is typically what a diagram would look like, where you have these cells set up around the floor, and then the arrows are showing the movement of parts from cell to cell. We affectionately call this a spaghetti diagram, and this is a good example of what they typically look like. In this type of a setup, you typically see high inventory, and it's not just in the raw and the finished goods, but a lot of work in process. And the reason the work in process goes up is there is a buffer inventory in each one of these cells. So the inventory builds up, it gives them a little bit of safety stock, and then they can move from cell to cell. So that's one of the issues, is high inventory. It has long throughput times, because if you calculate the time that when something starts in the first cell and goes all the way through the process and becomes a finished good, it's a long time. Okay, and that creates labor inefficiencies, not only due to the process, but what happens in a batch process is usually, and quite often, the workers are dedicated to a cell, and even sometimes dedicated to a machine, because they become experts at that. And therefore, when that cell doesn't have any orders, it's not as easy to move them from one cell to the next. So you end up with inefficiencies because you have too much labor and you don't have the flexibility to move them around in the plant. It also creates a lot of indirect labor. In order to keep a process like this going, you have to have a lot of support personnel. So indirect labor, in our definition, includes things like supervisors, quality, you have material management, you have purchasing, and then you have fork truck drivers. And one of the things that I look for when I go on plant tours and listen for are the beeps. And when I go into a plant and I hear those beeps, I know that there's fork trucks moving parts around, and every one of those fork truck drivers typically has a dedicated driver, and that's all indirect labor to keep this process going. And so it creates high indirect labor. You also get safety issues in this environment, and those safety issues are very typically also like quality issues. And that's because all this movement that's going on, usually in a cellular and a batch process like this, parts are moving by, on crates and things like that, and they're moving by fork truck, and the operators are having to lift them and work in the cell and then put them back, things like that. And that also creates quality because the parts are moving around a lot more than they need to. And so these kind of go hand in hand. You get safety and quality issues. And this is similar to Billy and the family circus, where, in the beginning, in the bottom left, Billy is given a very easy, simple task to get this mail to the mailbox on time. But as it goes through the process, he's distracted. It takes too many steps. And ultimately, he announces on the right-hand side here that, he missed the delivery. He missed the on-time delivery because of all these distractions. So we like this diagram to show kind of what a batch process looks like. So I had an example of this. I ran a division that had two different factories. In fact, they were in different states. And we were manufacturing highly engineered but standard products. And we made 600 products in these two factories. And they were being shipped. They were similar in the product category. They were sometimes being shipped to the same customer, but they were manufactured in different facilities. And so this was a batch process. And it resulted in the high inventory that I mentioned. And a lot of the inventory was, again, this buffer stock that was, stuck in the process all the time. And we had very high conversion costs, the direct labor and manufacturing overhead. And the high level of this was not only in the direct labor, but all this indirect labor that was sitting in the manufacturing overhead. These things combined led to a low profit, less than 10% profit in the organization. It also created long lead times. As I mentioned, you have these lead time issues with throughput through the process. So our lead times, our customers were expecting orders to be delivered in 2 weeks. We were delivering about 6 weeks, and we weren't even doing that all the time. So this also had poor on-time delivery. We were only delivering these 600 products in the 6 weeks. We were only delivering them at about 80% on time. So this was a big problem. It also created quality issues, as I mentioned, because we had these cells and we were moving parts from one to the next. We had quality and, again, higher safety issues than what we certainly wanted and expected. The combined workforce, when we looked at this, was about 200 employees. And when we look at that, we also look at the ratio of direct to indirect. And as I mentioned, those indirect positions are keeping the direct employees basically busy. And so 200 employees, we had about 125 direct. The ratio was about 2.33, when we got started. This was also what we call a FATS organization: fabrication, assembly, test, and ship. And most of the fabrication, these were things in the operation that a lot of the machinery was fully depreciated. And when that happens, you typically have a dedicated operator because he or she, they're the only ones that know how to run that machine. And so this limits your flexibility because we couldn't move them to assembly because they were really experts at running, these machines that were, not a lot of new equipment in the factory. So when we got started, and again, I was running these two businesses, we looked at this and it was, a bad situation for us, low profit, a lot of complexity. And it was even worse for our customers. And so we looked at this, there was a lot of opportunity for improvement. And so what we did, we improved the operation by combining the 80-20 and lean principles. The first thing we did was we simplified the product line. We took 600 products and we reduced them by 100 and ended up with 500 products. And so some people, hear this and they're concerned about 100 products. Well, we were only giving up, according to the quartiles that Jen showed earlier, this was a lot of quartile 4 products. So it was less than 1% of the revenue, but it was 100 products. So the first thing we did was we simplified the product line. So now we have 500 products left over, and 100 of the products actually represented 80% of the revenue. And so we had this 80-20 relationship. We converted, now that we're back on track, we converted to an ATS manufacturing environment. And so we outsourced a lot of the non-core processes, what we call the INGs, the grinding and the sanding and the drilling and the painting. Those INGs, we basically we weren't really good at it. And once we simplified the product line, we found outside vendors and suppliers that were able to do this and do it cost effectively. A lot of the problems we see with manufacturing operations is when they try to outsource, The suppliers don't want that business because it's too complicated. So they charge you high prices to do it, or they just say, no, we're not going to do it. But once you simplify the product line and raise the volume and of what you're buying and what you're having processed on the outside, it's much easier to find outside partners to do that. This also gave us a lot of flexibility to cross-train the workers. Now they were primarily doing assembly, test, and ship, and we were able to move them from cell to cell in these assembly cells. And so we didn't have them dedicated there. What we were doing is moving them to where the orders were. So instead of having them dedicated to a line and building product for inventory, we were moving them to where we actually had orders. And we inlined the production, as John mentioned, by putting all the inventory at the point of use, single piece flow, putting everything in line, giving them all the tools they needed. It not only made it a lot more efficient, but it also reduced the quality issues we were having and those safety issues. So overall, this was turned into a much better situation. And in the end, the results of this were we closed the smaller facility. We moved all the operations to the larger facility. And as remember, I mentioned, a lot of our customers were buying products from both facilities. So now we were more efficient in the shipping operation as well. We reduced the manpower from 200 to 100, and the ratio also improved. We like to see that ratio as high as possible. So now we were at a 4-to-1 ratio, everything being in one facility, simplifying the product line, putting everything in line. We got a lot more efficient, especially with the indirect labor. This significantly reduced the lead time. Remember, we were at 6 weeks. We were able to reduce lead times to 2 weeks for our highest volume products shipping to our highest volume customers in Quad 1. We got that down to 2 weeks, and we were able to do that 98% of the time. So much better customer service, especially for those high volume customers. We had a significant reduction in the inventory. We reduced that by about 40%, mainly by taking out a lot of that WIP inventory and also focusing on the high volume parts that were now moving much faster, turning over much faster. We were able to bring that inventory down. So this is the one key here. We were improving on time delivery while also bringing the inventory down. So the profit for the overall business, increased from 10 to 20% in just under 3 years. And the return on invested capital, which is the profit divided by the working capital, that improved from about 8% to over 22%. So in the end, this was a much better situation, not only for our company and the results, but also for our customers, because we were able to significantly improve, reduce lead time, and improve on-time delivery and improving quality at the same time. So now I'll turn it back over to Jen. She has some additional comments, I think, in closing this portion of the meeting on inventory.
Yeah, thank you, Mark. That's a great example. And I was thinking about a client that we just outsourced some of the fabrication with a couple months ago. Just what you're talking about. There was a concern we are too customized. There's not enough concentration in our fabricated parts to turn over to a partner. We worked through that process. We applied an 80-20 approach and Quad 1 lens. And when we found that partner and outsourced this particular component, we saved at the material margin line. Because there are people who do this better than us, and it's their core value add to us as assemblers. And the fabrication of this particular component had nothing to do with my client's value add to their core customers. So they were shocked. I wasn't shocked. We've seen this a lot. So not only did it free up the indirect labor, free up the direct labor to work on more throughput of broader margin product or higher margin product, it saved them at the material cost line. So we can't make this stuff up. It's real. We love it. And I did want to end with an example on inventory. So Mark and John did a great job walking us through what a holistic overhaul to your flow and manufacturing facility can look like if you first apply 80-20. So that is completely enabled through the lens of 80-20, simplification of the portfolio, focus on your Quad 1 customers, and you can overhaul the way you do these things. Do not be discouraged if you're on the call saying, man, I was really hoping to walk away with an action item now. How do I apply something immediately? Because this is an example of that. You do not have to wait for the overhaul to start applying 80-20 thinking to your operational challenges and opportunities today. And this is an example to highlight it. So I started working with a client in May, in particular focusing on their inventory and what was going on. This graph on the left, I have removed the actual values, but what you can see is exactly what Marc said at the onset of the call. So their on-time delivery is going down despite the fact their inventory dollars are going up and their backlog is going up. So I'm getting orders, I cannot ship them, and I'm getting inventory. Again, it requires every component of my bill of materials to actually ship and fulfill that order. And so my on-time delivery is going down. And so there were we had to take a two-pronged approach to this. One, what are the critical few components and how do we apply a lens to thinking about that and how we're going to source those to ensure we can have throughput in our production facility. And the other, of the things that we have over purchased on, tying up a lot of our cash, how are we going to solve that systemically? So I'm going to talk about that second portion. Because their cash position was doubly crippling, right? I have all this cash tied up in inventory, and I also can't produce to collect more cash from customers. So what we did was we took an extract of their perpetual inventory, sorted that high to low, like everything, descending dollars. And you won't be surprised if you do this. There's thousands and thousands of SKUs in WIP, raw, and finished good that you carry inventory on. Focus on the top 100. It's going to be close to 50% of your total inventory dollars. And then go very deep, methodically, just on those top 100 and understand, why do I have so much on hand? How much do I typically consume of it? And drive yourself to what was the root cause issue that led me to have too much, if that is the case. If it's a high turning item and you're carrying the right amount, fine, move on to number 2. But you're going to have a lot in that top 100 where you have way more than you should be carrying on it. And get to those root cause drivers. Is it a min-max issue? Is it a queuing time? Is it safety stock? What are the reasons why? Once you understand that, look for a solution. Should I move to consignment? Can I do just in time? How can I remove this lead time, this queue time? Because the mill metals is a huge problem with this particular client. The mill's just down the street. So why am I carrying so much sheet metal in my inventory? And this is the hard part. Everything I'm saying right now, I bet a bunch of you are going, how simple and easy is that? Mm-hmm. A lot of things 80-20 appear simple and easy, but the hard part is staying rigorous, focused, and diligent on just those few things. Because what keeps happening is we go down this very deeply on one SKU that we have too much on. We understand why. And then my client will go, okay, this applies to this whole long tail of suppliers that I also have this practice with. Let me go through and spend the time to fix every single one of those suppliers. And that's where we have to say, no, put it in the parking lot. Because we have a precious few resources that can work on driving down the biggest inventory dollars today. So once we get to that level of importance, we'll go back and fix that eventually, but not now. Let's go back to the next highest dollar amount. And that's how we have to evolve from I want to do everything 100% correctly to I want to be 100% correct on the top few that really materially matter in my business. So on the right, you can see where we are right now. Just since May, we've freed up $20 million of cash through lower inventory values with this client. Their on-time delivery to the A customers, is back up. It's in 95% range now. Again, we separate everything A's from B's. And their backlog with the A customers is again returning to normal levels as we're prioritizing their lead times and their delivery dates. So this is something you can walk away today and start thinking about, how could I incorporate 80-20 to this challenge in my business? So that is a lot of what we prepared. Then the next slide is a quote about change. We encourage you, change is inevitable. We've gone through hyperinflation, tariffs, COVID, supply chain constraints, all that fun in the past few years. And it's inevitable. So apply an 80-20 lens to things as you go through these changes, and you will have the best success of coming out smoothly on the backside. So we want to open it up now to questions. Did we get any questions, John?
Yeah, John, Mark, and Jen, thank you so much for that. We do have a few questions. One of the biggest issues facing manufacturing right now is supply chain and the issues the challenges that everybody's facing with that. So how does the 80-20 and inlining process help with the supply chain issues of today?
Yeah, I can address that. The main thing for me in putting in the inlining is visibility and timing. If you think about a lot of businesses, the suppliers aren't sure what they're going to be supplying, when they're going to be supplying it. They're not willing to take any risk until they get an order, and then they have to go source their materials. And with inlining, you not only have, because you've simplified everything, you not only have better visibility of what you're doing and you have some stock on that, but your suppliers, especially if you teach them the same things, are going to do some of those same things. And now you're going to go maybe from like 2 weeks notice to maybe 3 months, 4 months of visibility, where they can see a problem that may be coming at them long before it ever gets to you. I think that's the major benefit, is the timing and the visibility.
Okay, excellent. One of the questions was, how does this analysis take into account pricing and gross margin? Not all revenue is equal. The Fort is going to have far skinnier gross margins, all things being equal.
Yeah. Yeah, I can address that. Yeah, I think this question came up during the presentation of the quartiles. And so you have 89% of your revenue in quartile 1. We showed 25% of the effort. And whoever asked this question made a really insightful question, because we weren't talking about the margin. And we do agree that quartile 1 is typically going to be less in margin, and it should be. Your largest customers should get your best prices. So let's say that the gross margin, if we're talking about margin, the gross margin is 80% in quartile 1, not 89%. Well, it's still 80% in gross margin. There's only 25% of the organizational cost. It is still at least 150% profit. And so here you need to, you need to go away from getting hung up on the percentages, but look at those gross margin dollars that are being created in quartile 1, and they're basically paying for the whole organization, because you're getting 150% pay, return on payback there in quartile 1.
I think I agree with everything Mark said. And to add on that for that question, sometimes the best way that we like to do it is true material margin, because we understand that it's directly assigned to the BOM, and remove any allocations that we've made into a standard margin based on the revenue of that customer or product. And that will help us see more clearly what Mark is explaining.
Yep, good point.
So I think a really good question just came in. It says, how should I think about what a product is? Is it the SKU, or can it be a group of SKUs? For example, if I sell a product with various configurations, what should I be looking for in trying to apply 80-20 thinking?
Yeah.
That's a great question. So we look at things a lot of ways. If you truly produce at a SKU level and you have SKUs with built BOMs in a system, then we want to analyze it at a SKU level. If you are a configured to order or engineered to order business where everything is a snowflake and your repeatability is 1, it never repeats, then sometimes we'll look at families. We'll look at configuration options. I have an example of a client I'm working with who is that. It's an engineer to order massive capital equipment. When I was walking through their factory the first time, I said, how many different door sizes do we manufacture here? I'll do it in any 1/4 inch increment. Any 1/4 inch. Well, so you can see how you can't really pull a SKU list to make the analysis. But when we did standardize, when we looked and pivoted all their data with all the proliferation, there were like 4 doors of infinite options that we tend to sell the most on. So let's Kanban those. Let's just focus on those. Let's forget the rest. So you can look at by family. If you sell in SKUs, we'll look at it by SKUs. Either approach can work.
And I'd like to add something on to what Jen said. When you take a look at those products that are in your first quartile, and those are the ones you want to inline, you can take a look at, as I think the question alluded to, families, and what can we possibly do on a given line, and what's so different that we can't do that. And that's why engineering can play a large part in making things modular and trying to take a look at function and design. And if it's doing the same thing, why can't the design be the same thing? If the design can be the same thing, then we ought to be able to simplify it even more. The example that I gave, to do the various configurations of manual and automatic and so on, there was over 10,000 parts to build those configurations. What ended up after engineering was done with it was a little bit over 1,000 parts that could be assembled in different ways to achieve all of those same things that the customers needed.
How can this be applied to high volume manufacturing, such as fasteners or stampings?
Yeah, I can start with this one. I mean, this really works well with high volume manufacturers. Normally we're on the other end of the spectrum, which is short runs and specials and things like that. But high volume of fasteners and stampings and similar things like that. The important thing is, because what happens is they tend to run everything down the same line. And then you have some long runs, and then you have a lot of changeovers to run the short run fasteners. Let's use that example. And so what we like to do is separate those and dedicate lines to the high volume runners. Sometimes a line could be dedicated with no changeovers. It may not be running all the time, but no changeovers. It's always running the highest volume. And then have another line that specializes in short run fasteners. And actually, from my experience, we like to separate the workers that way too. Some workers like to do the same thing every day, and they're very good at that. Other workers like to have something different every day, and they're very good at that. So we like separating what we call the 80s from the 20s. And even in the same factory, that's a more efficient way than having one line that's constantly being changed over and over again.
So another question. So how can you connect SKU reduction to the dollar benefits?
Oh, that's great. So I have a client that I'm working with right now where this is a lot of what we try to teach is how are you quantifying the impacts of what you're doing in a way that you can see it in the P&L. So it's a lot of what we teach the people and our clients that we work with. So I like to use a kind of a margin expansion tracker. I am simplifying my business. What is that doing for me? How is it freeing up direct labor hours in the example that Marc talked about in the batch to inline transition? I free up these direct labor hours. Okay, what do I do with them? Do I just reduce them? Do I then instead put more through my factory? And how much more is the profitable? How much more profitable is the product that I'm choosing to replace that capacity with moving through my factory? So it's quantifying thinking about the flow of a SKU through your operation and saying, if I'm reducing this, what complexity and what activities of work are going out the door with it, and what is replacing it? So that's how we wind up truly quantifying the impact of our simplification efforts.
So where do you find the most common areas for reduction of indirect labor? Is it in supply chain, quality, production managers, et cetera? Where are you finding the most common reductions?
You want me to take that one, start with it? I think the examples that were given are good to say, it's across the board. We tend to look at indirect labor, but I can tell you in my example that I gave with the two factories that eventually went into one, we reduced a lot of the supervisors because they became, self-led with a team leader instead of having a supervisor going around checking on things. The fork truck drivers, we ended up not having a driver dedicated to a fork truck, but we had a fork truck that was there, and people would go over, they were trained to use it, and they would unload trucks. They would put the products, take them from the truck and take them right to the line. And then on the finished goods side, they would load the truck, but then they would go back to work. And so a lot of it was in every one of these areas. Quality, instead of having dedicated quality people going and checking in everything, we built quality into the process, and the operators were responsible for quality. And if they saw a problem, they were responsible to stop and to get a fix to that problem. So it was really across the board, but the supply chain was in the question as well. It does have to do with reducing the number of suppliers, and then you don't need as many people to do that. And expediting and material management, all those things can come down if you really focus on simplifying that operation.
So along with that, then are you applying additional metrics to those different areas? X persons per number kind of thing?
Yeah, I don't know if I've ever, maybe the others have examples, but I don't, say how many suppliers can one purchasing person handle? I think it's good to start with what do you have today? And then if we're going to simplify this, then in the future, we won't need as many. But I don't know if the others have any examples of specific metrics in the indirect labor category.
Not in the functional level. I mean, we talk about the Strategex key ratio generally, which measures, what's happening to my material margin and the relation. Again, I won't have time to wrap it up, but there's a great recording on our website. I recommend you check out on the key ratio, but it's how we're leveraging overhead for our margin dollars over time. And simplification is informing that leverage. So not specific to function, but overall we can do it that way.
Great. Well, Marc, Jen, and John, thank you so much today. And I want to thank Strategex for putting this on for us today.